Good morning, everyone. Today is lecture number 36 of this heat treatment class. And today's topic is on aluminum alloys. Basically, this is a completely new topic because in earlier lectures, we have been discussing about the heat treatment of steels, right? But now we'll move to the heat treatment of aluminum alloys, which is a non-ferrous alloys, right? Now, so before going into that, we should know something about aluminum alloys. So, these are the today's contents. You can see aluminum alloys, cast and wrought aluminum alloys, aluminum alloy designations, properties of base aluminum alloys, and its application. And the last one, heat treatable and non-heat treatable aluminum alloys. Okay, so we'll start with aluminum alloys. Okay, aluminum properties. Already you have been gone through these topics like in non-ferrous metal extraction subject, where you have been come across these properties of aluminum. So aluminum, if you carefully look into the surrounding, then the most used material is the concrete first, right? Then after concrete, steel comes. Then after steel, aluminum comes, right? So just after steels, aluminum is the one of the most used material we can see. So so aluminum is very interesting, obviously. Why? So aluminum has very interesting properties. If you look into the pure aluminum has very attractive properties. Like the best attractive property aluminum has, it's lightweight, huh? It's lightweight, or you can say it has low density. If you compare the density with steel, it is very light. It is having very low density. It is lightweight, right? So you can say, in other words, I can say, if you compare the aluminum with steel, then you can simply say it has high strength to weight ratio. The weight is less, but strength is high. It is very interesting, right? So these applications, because of this interesting uh, property of the aluminum, this is used in aerospace applications, making aeroplanes bodies, aircraft bodies, fighter planes, right? Where we need a very lightweight materials. And nowadays, aluminum has been also used in automobile industries. A lot of applications are there. We'll see that. Basically, we are not using aluminum, rather than we are using aluminum alloys because we need strength also, right? The second important property of aluminum is the corrosion resistance. It is highly resist corrosion. So the aluminum materials will not get corroded easily like steels, because steels will get corroded, but there are certain grade of steel like stainless steel they do not corrode, but other steels, carbon steels basically get corroded. But here aluminum is highly resistant to corrosion because of the aluminum oxide layer which forms on it. Because this aluminum oxide layer will not get eroded, it will not get removed. But in case of steels, the iron oxide layer get removed, right? So new surface get exposed to the atmosphere and corrosion will continue. But in this aluminum case, it doesn't happen basically. So this is two important property of the aluminum. And if you look into the pure aluminum have high electrical and thermal conductivity. And another interesting point, which obviously you understand, high electrical conductivity means they're used to make electrical conductors. Like uh, if you have heard in the non-ferrous, uh, basically the overhead lines, the overhead cables, those are made up of aluminiums basically because of its high electrical conductivity. Hmm. It is cheaper, obviously, and the core is made up of steel, but the outer part is made up of aluminium, right? And you know why the core is made up of steel? Because these aluminum wires are very long and they do not have such so much of strength. I'm talking about pure aluminum. So they need strength. So the strength will be provided by this steel, but the electrical conductivity will be provided by the aluminum, right? Because you understand they are long wires, they may get bend. Bending may take place. So strength is required. So that is provided by the steel. Okay, fine. But the problem, the limitations with aluminum is the limitations. If I am talking about the limitation of pure aluminum is what? It is having low strength. But that is that is another advantage you can say. If I can write over here, very high ductility. That's why we are making aluminum foils. So one of the major application of aluminum, pure aluminum, basically you can see we are making aluminum alloys. Sorry, that is aluminum foils. These foils are very important in packaging industries. Fine. Then okay, fine. It has low strength. So due to this limitations only, we are converting aluminum into aluminum alloys. So obviously, what is the need of converting aluminum into aluminum alloys? To enhance the strength, to enhance the mechanical strength, and sometimes corrosion resistance also, and etc. We can increase the corrosion resistance further by adding alloying elements. Okay, what are the alloying elements present in aluminum alloys? So basically, uh, aluminum is also very interesting because it can form alloys which have many applications. Uh, so those alloying elements are basically, I can write copper. It can form alloying element with copper. It can form alloying element with manganese, Mn. It can form alloying element with silicon. It can form alloying element with copper, manganese, silicon. Then it can form alloying element with yes, magnesium, Mg. Then it can form alloying element with zinc. Very good, zinc. Then other alloying elements. These are the major alloying elements. Other alloying elements are chromium, nickel, lead, bismuth, and lithium is the nowadays it is the work is going on still now. These are the alloying elements. Fine. And here the each alloying element have a definite role to play. Sometimes in aluminum alloys, a single alloying element may be there or multiple alloying element will be there. But from those alloying elements, one or two will be the principal alloying elements or the major alloying elements which will decide the properties. Right. And other alloying elements will be like it is a bonus. I mean, it can like reduce some deleterious effect of the major alloying elements. You can see. Okay. We'll see that soon. The okay, then aluminum cast and wrought aluminum alloys. So aluminum alloys can be cast aluminum alloys. It can be wrought aluminum alloys, right? That means some aluminum alloys have very high uh, castability nature, very high flow nature. So they can be converted into complicated shapes because of high castability nature or high flowability nature. They can go through any complicated designing of the mold, and you can produce any complicated structures, intrinsic structures, intricate structures, right? Wrought aluminum alloys, you understand that means you have to plastically deform it, and you can give a shape and you can use it. So casting process for aluminum alloys is like basically die casting. Die casting means you can do either pressure casting, pressure die casting, applying pressure, and you can do gravity die casting. So this is basically die casting. Die will be there, then you have to insert your molten metal into that forcefully, and you can get a shape out of that. And you can also do sand casting sometimes, and other castings also. Wrought aluminum alloys means, as I told, wrought here means wrought aluminum alloys. That means those aluminum alloys on which mechanical working has done already. So those are maybe rolling, you understand, rolling, forging, extrusion, right? Deep drawing, right? These are the things. So you understand why heat treatment is essential, because we are doing mechanical working. Sometimes we need high ductility, so we can, so that we can deform it more and more. This is one of the point I am saying. And sometimes these are alloys, we can go for strengthening also. So heat treatment is essential in that case. If I can write here, need of heat treatment, need of heat treatment in aluminum alloys. So one need is strengthening, and the need is we can do brings ductility, so that we can deform it more and more. We can do rolling, forging easily if we have a high ductility. So if you look into the wrought aluminum alloys, they are in form of, so different forms I can write, different forms of wrought aluminum alloys. Obviously you can understand shape, coils, bar, plates, right? We can have wires, etc. Right? Then aluminum alloy designation, yes. So this is the one of the important part. If you are supposed to appear in interviews, or you are supposed to do any research, or suppose you are working in an aluminum industry, so you should have this knowledge at least. What are the different designation to the aluminum alloys? So I can 1, 2, 3, 4, 5, 6, 7. Okay. So aluminum alloy designation. So aluminum alloy designation is given by AAA, that is Aluminium Association of America. So USA basically designate the aluminum alloys, that is Aluminium Association of America, and this designation have 4 digits basically. This designation includes 4 digits. Like steel are also designated with the help of 4 digits. So here also they are designated with the help of 4 digits. Four-digit designation. So like 1 to 8 and triple X, right? This is a way of designation. So we have 1 triple X to 8 triple X, fine. Or some people say 1000 series to 8000 series, fine. So I'll write over here. So first, so here basically I'm writing the designation 1 triple X. Similarly, I can copy this. So I can write 2, I can write 3, 4, 4, 5, 6, 7, 8. So now I can write 2 triple X, 3 triple X, 4 triple X, 5 triple X, 6 triple X, 7 triple X, 8 triple X, right? These are the different groups actually. This is one group. Under this group, many alloys will be there. Under this group, many alloys will be there, right? So now all these groups have a principal, or you can say measure alloying element. That means by looking at that alloying element, you can say that this aluminum alloy come under this group, right? So first one is one, and as I told, these are also called 1000 series, 2000, 3000, 4000, 5000, 6000, 7000, and 8000 series, right? So measure alloying element in 1000 series is no alloying elements. I'm writing. There will be no alloying elements in 1000 series aluminum alloy, or in 1 triplex there is no alloying elements. So what is this then? This is commercially pure aluminum. So commercial grade pure aluminum is comes under 1000 series. So basically it is, you can say 99% purity. 99%. 99% pure aluminum. Fine. So basically, some people say like this: the last last double X, last two digit double X, or last two digit signifies the purity of the metal. Here I can write last two digit gives the purity of the aluminum. If you have gone through any literatures or any data from industries, you might seen that they used to call like my aluminum is like 99.99% pure. Some people will call my aluminum is 99.999% pure. Nowadays they are saying like this also. That is 4N, 5N, 6N, 7N, 8N, like this. 4N means 99.99, 5N means 99.999, 6N means 99.99999, like this. They are saying like this nowadays. So last two digits in the first series will tell about the purity of the aluminum. And the second digit indicates the modification in the impurity limits. If the second digit is 0 here, it indicates unalloyed aluminum having natural impurities. Right. Now 2000 series, the measure alloying element is the copper. Copper is the measure alloying element or principal alloying element. Fine. So it can be alloyed further with magnesium and all. Fine. Depending on the requirement. And if you have gone through your phase transformation class, you might have come across this kind of aluminum copper alloys, aluminum with 4%, or aluminum with 2%, aluminum with 3%, or aluminum with 4.5% copper, right? then 3000 series basically, okay, fine. Here, just carefully look at the slides and just listen the lectures carefully. Here I want to tell you an easy way how you can remember which alloying element is there. This is my own way to remember the which kind of alloying elements are present or measure alloying element for a particular series. So how I remember? I remember like I'll start with 7 here. 7 is, you have to remember zinc. Why I remember the 7000 series? Because 7000 series is the most important group of aluminum alloys which find applications in aerospace applications now or in defense applications. But that means they used to make fighter aircrafts, fighter planes, right, or normal planes nowadays. And this group of aluminum alloys nowadays is going to replace steel in case of automobiles. Nowadays, automobiles are made up of these aluminum alloys because of its high strength. And you have to remember another important point: 7000 series aluminum alloys have very high strength, and some of the alloys have the strength equivalent to that of steel also. Not all kind of steel, few category of steels. Basically, you can say carbon steels. That's good strength. Fine. So, anyways, so zinc here, sometimes zinc with magnesium, zinc with magnesium, right? But major alloying element is the zinc, right? Then 6000 series, I have remember this is magnesium and silicon both, fine. Why I have remembered these things like this 2000, 6000, 7000? Because 2000 series aluminum alloys, 6000 series aluminum alloys, 7000 series aluminum alloys basically are age hardenable aluminum alloys or precipitation hardenable aluminum alloys. The strengthening mechanism here is precipitation strengthening. A second phase particles forms on the primary phase, alpha phase, or you can say your aluminum matrix. Fine. So it is copper, it is, you can understand, zinc, and it is magnesium silicon. Now, how to remember other series? So you can see this is magnesium, M for magnesium. So now I can designate 3000 series like this. 3000 series, it is manganese. M for magnesium, M for manganese. So in this way I have remember. And now the 4000 series, I can write this silicon. Silicon is here, right? And 5000 series, I remember like magnesium only. Magnesium is here, this magnesium. So in this way I have remember. And 8000 series, this contains other alloying elements. Other alloying elements. Any other alloying elements I can write. Any other alloying elements apart from these alloying elements which I have mentioned here, right? They may be like lithium, chromium, nickel, lead, etc. Bismuth, anything else. Right? The most important category of these alloying elements is the lithium one, you have to remember. Why lithium? The problem with lithium is very reactive. So aluminum lithium alloys are basically processed in vacuum, right? Because they are highly reactive with the atmospheric oxygen, fine. But the interesting point about the aluminum lithium alloys is they are very lightweight, because you understand the position of lithium in the periodic table. It is very lightweight, very small size, so very lightweight. So aluminum lithium alloys provides you very lightweight, but the Young's modulus is very high, the strength is very high, corrosion resistance is also good sometimes. Fine. So new generation aluminum alloys, aluminum lithium alloys, fine. So this is the aluminum alloys designations on the help by using the principal alloying elements or the major alloying elements. Fine. I want to copy this here. Okay, better I will insert a new table. Now we'll discuss about the property of base aluminum alloys and its applications. So we'll discuss few applications, perhaps, and I'm sure. Okay, I'll not discuss in details, but I'll tell you some important properties and application. Let me insert few tables. I'm excluding 1000 series because you understand 1000 series is not an alloy. It's basically pure aluminum. So I'm inserted to this. Okay, fine. This is alloy groups. Now this is suppose properties. Or properties, and here application. So if you, okay, we'll start with the properties of 2000 series. 2000 series, as you remember, as I told, the major alloying element is the copper, right? So what happens? Copper, when present in the aluminum, provide precipitation strengthening, right? So it has very high strength, very high strength. So this is the, so application is obviously, you understand, aerospace application, making aeroplanes, aircrafts, fine. 3000 series here, if you remember, as I told, this is manganese, the major alloying element. The properties is, since manganese is there, so it has high or good toughness. Good toughness means good strength and good ductility. So applications is, okay, fine. So summary is going on right now, and you people prefer to have a beverage, like you want Coca-Cola or any thumbs up or anything, any soft drinks, right? So the main application is making beverage, beverage cans. So beverage cans are made up of this aluminum manganese alloy. Because of high toughness, good ductility, we can deform it. It has also good strength, right? Sometimes good corrosion resistance also. Beverage cans and the kitchen utensils, aluminum kitchen utensils are also this aluminum manganese. Kitchen utensils. Okay, so now 4000 series. 4000 series major alloying element, as I told, it is silicon. So you have to remember, this is one of the important group of aluminum alloys. I'm making it green. Let me make it green. Obviously, this is also important group of aluminum alloys. Aluminum silicon alloys, the properties is, the most important properties is high castability or high flowability. Flowability, right? Why? Because, can anybody guess why aluminum silicon alloys have high castability or high flowability? This is because when we add silicon into the aluminum at a definite compositions, it forms a eutectic compound, right? There is a easy melting, right? Formation of eutectic alloy. Oh. Basically 12% or 11.7% silicon in aluminum, fine. And another interesting point is you can see silicon is very lightweight also. The density of silicon is also near to the aluminum. 2.34 gram per centimeter cube. You can understand it is near to the aluminum. Aluminum silicons form eutectic, as I told, 11.78% of silicon in aluminum. And the temperature, eutectic temperature is 577 degrees centigrade. If you want me to write, I can write over here, no problem. You can write, otherwise 11.7 weight% of silicon in aluminum forms eutectic at temperature. So eutectic temperature is, you can understand, it is less than that of the pure melting point. Pure aluminum melting point. Aluminum melting point is 660 basically, right? So this is 577 degree. So one of the important application of this is the cast alloy. This can be easily cast into very complicated shapes. So engine blocks, automobile, so automobile engine blocks, which is the main part of the engine, you can see. Engine blocks, because engine blocks are very complicated shapes. And also car steering, knuckles. Basically, in automobile industries, they are used aluminum silicon alloys, right? And aluminum silicon is nowadays also used in electronics also. And if you look into any other properties, as I told, decrease in contraction upon solidification. So silicon decreases solidification contraction. And very easily available. Okay, I'm not writing here. This one. Then 5000 series. Now for 5000 series, as I told, it is magnesium and silicon both. Sorry, it is Basically 5000 series is magnesium only. I'm writing here magnesium, and aluminium magnesium when combines provides very high corrosion resistance. Good strength. We can say we can do work hardening on it easily. Basically very high corrosion resistance. I can write to marine environment. Marine or saline water. So they find application to make ship hulls. You understand? Making ships and storage tank. Because of high corrosion resistance. Storage tank and ship hull. 6000 series. It is both magnesium and silicon. Yes, it is magnesium silicon both. The property is a combination of properties, and basically they provide high strength, due to precipitation. So again, they can find application in aerospace or any automobile making industries, or where high strength is required. Basically 7000 series is the major alloying element. I told zinc. So here properties is very high strength. You can get a strength of 700 MPa if we have zinc in aluminium, or zinc with magnesium also. So automotive, defense, marine, aerospace. If you look nowadays, the Audi cars, as I told, I've been saying many times, the Audi car, the new generation Audi cars, they are basically made up of full aluminium. There is no trace of steels. So they are made up of these 7 alloy groups, 7000 series alloy groups of aluminium. And 8000 series, I told other alloying elements, any other alloying elements. So depending upon the alloying elements, they have different applications, like aluminum, lithium, as I told, they are used in making aerospace industry, making aeroplanes and all. So now we'll move to the next topic, that is symbols for condition of aluminum alloys, or some people call temper of aluminum alloy. So suppose in the market, the aluminum alloys are sold in a code name, in a symbol name. So you have to remember those code or those symbols for a definite condition of aluminum alloy, right? We'll discuss that. For example, I'm writing the conditions I'm writing the I'm writing the condition of aluminum alloys, or aluminum alloys temper, and the symbol given. symbol given to that. So first is, suppose you want an that is as fabricated aluminum alloys, no? As fabricated. So as fabricated aluminum alloy symbol is basically F. Then you can go and you have to ask, like, I want F aluminum alloys. That means you understand as fabricated. As fabricated means you understand maybe cold rolled or hot rolled. You can also tell them I want cold rolled one or hot rolled one as fabricated. Fine. Next one is, suppose you want an aluminum alloys which is fully annealed. Fully annealed condition aluminum alloys. You understand, fully annealed aluminum conditions means already annealing heat treatment has been done so that it is very ductile. Okay, so it is denoted by O. This is F and this is O. Then suppose you want solution treated aluminum alloys. So that is W. Sorry, solution heat treated, huh? Or solutionized. Solutionized solutionized. So it is W. Symbol is W. That means obviously, suppose you want only solutionized aluminum alloy, it is W. Then suppose you want solutionized and aged one also. Then it is T. And we have a lot of variety of T conditions aluminum alloys. We'll discuss that maybe. And the one is strain hardened aluminum alloys. Strain hardened aluminum alloys means, you understand, strain hardened means work hardened aluminum alloys on which some cold working has been done, basically hot working or hot and cold both. That is denoted by capital H. So these are the different symbols given to different condition of aluminum alloys available in the market. Right? So now we'll discuss about the heat treatable and non-heat treatable. Okay. So now that means we can have aluminum alloys which are heat treatable aluminum alloys, and we can have a non-heat treatable alloys. Why we are discussing? Because you understand whether they require heat treatment or not. Right? This subject is heat treatment. Basically, the difference lies heat treatable non-heat treatable. So you understand, non-heat treatable aluminum alloys means they do not show any change in behavior, right, upon heat treatment, or poor response. I can say poor or no response. Poor response better, right? Or no response. Poor response to heat treatment. That means their strength will not improve upon doing heat treatment. The strength will not improve. Here, basically, the strength show very good response to heat treatment. That means strength improved upon suitable heat treatment. So, which category of aluminum alloys comes under this heat treatable aluminum alloys? You understand? Those aluminum alloys which form precipitates, or upon aging, or which forms precipitates and provide precipitation hardening. So those already we remember 2000 series, 6000 series, and 7000 series. This series of aluminum alloys are heat treatable aluminum alloys, and others apart from this series, all other series are non-heat treatable. So you can understand the heat treatable aluminum alloys and non-heat treatable aluminum alloys are classified on the basis of whether they are forming precipitates or not, or whether they are showing precipitation hardening or not, right? The important feature of these alloys, what is the most important feature of these alloys? That is precipitation hardening. How precipitation hardening is coming into the picture, that is important actually. So I can write equilibrium solubility of alloying element or elements is different at different temperature. Basically, it is common to everyone, but in what sense? That means at room temperature or at low temperature, alloys have very low equilibrium solubility. Whereas at high temperature, we have high solubility. Whereas, or I can say the solubility of the alloying element in the matrix is reducing with reducing in the temperature. It do not happen here, right? Basically. Okay, I'll stop here. I'll continue the lecture from the next class.